Because of our small team size and aggressive goals, we try to outsource as much as possible. We use Sentry for crash monitoring. Studsig is our experimentation framework. We have some wrappers around it for our injection scopes. For analytics, we use a custom solution based on the Segment open source library. For logging, we use Datadog. And we also use Google tempering protection for our binary. Hi again, I'm Anton Todanaev, one of the first Android engineers on ChatGPT team, and excited to share our journey for developing ChatGPT app from scratch. I want to start with an overview of what I will cover and won't cover. So it's mostly going to be our tech stack, architecture, learnings from building the Android app from ground up. There won't be much information about AI or LLMs. Instead, it's going to be general Android development experience. And I think it's going to be relevant to a lot of Android engineers out there. So especially, I think it's useful for someone who's just starting building an app with all the modern tools and frameworks and plan to scale to a larger audience. Here are the milestones of ChatGPT Android app development. We kicked off in May 23 with just 3 Android engineers. We launched the app by July 23, which is less than 2 months from zero to public launch. So by January 24, we achieved 50 million downloads on Google Play and 100 million by June. I expect continued fast growth driven by countries with high mobile usage and app-specific features like voice mode. And let's dive straight to some technical details about our app, starting with module structure. So we have app module, which is obviously the main module where we have navigation graph, MainActivity, create all of our main injection components. Then each feature is built in isolation and feature modules. We usually split them up into API implementation for build performance purposes. So we have also platform, which hosts all the common code, things like networking, storage, other utility functions go there. We used to have something called subsystem, which is basically stuff that we share between many features, like, for example, APIs to retrieve list of available models used across many features. But there was no clear divide between that and features, so we just decided to merge it together eventually. So it's been a flexible architecture that kind of helps us grow and but keep the code base organized. Gradle convention plugins, if you don't know, it's basically plugins that help you organize your Gradle files and keep them clean and maintainable. In the past, I remember sometimes copying Gradle files just to get all the necessary dependencies I need. But you get also unnecessary dependencies that way, and it's just not a great way to maintain your Gradle files. For example, if you don't change something across all modules. Yeah, so basically, convention plugins solve that problem. We have, so this is the kind of list of convention plugins that we have. We have Kotlin library, Android library. Those two are usually used in platform modules. So Kotlin is something where you just need pure Kotlin. Android is if you need some Android dependencies. Then we have Android feature plugin, which is the feature API modules, Android feature implementation modules, and another plugin just for the main app module. That's just so we can share configuration between different plugins. Strongly recommend if you still haven't decided on how to organize your Gradle files. And this is just an example of what a simple feature Gradle file could look like in our code base. It's just 5 lines of code, and it includes all the basic dependencies we need, like Compose, our UI library, and all sorts of other basic dependencies. Let's talk a bit about pure Kotlin versus Android modules. At the beginning, we tried to keep as many pure Kotlin modules as possible. For example, most of our API were pure Kotlin. We use Ktor, which supports Kotlin multi-platform. It was a pain when you needed some small Android API dependency. You either have to create a separate module to just abstract the API or convert everything to Android. And then we decided that most of our modules can be Android. It's just easier, and so far we didn't need to share any of our code base. So if, depending on your project, you might lean one way or another. If there's a chance of reuse, it might make sense to put more effort at keeping pure Android modules where possible. Let's talk a bit about CI setup. This is what it looked like when we just launched ChatGPT. So lint, detect, unit tests, pretty standard stuff. We also use snapshot testing a lot. We use emerge for that. Helps with regression testing because we have Compose previews everywhere, so you get pretty decent coverage without without writing any tests explicitly. It caught quite a few dark mode issues for us. Sometimes it can be flaky when you have animations, but I still recommend it if you use Compose previews. Our release process for, originally we used an external vendor, but then decided to bring everything in-house because it was important for visibility into the process and have full control over what's going on. Yeah, so currently our setup is quite a bit more complicated. We have a task for GraphQL schema generation, localization, and some other stuff, but that's the minimal set you probably need if you're just starting. And we use GitHub Actions for our CI. We don't have a dedicated person that handles CI and build tooling, so it saved us a lot of time. Also recommend. Because of our small team size and aggressive goals, we try to outsource as much as possible where it makes sense. We use Sentry for crash monitoring. Originally, we tried Datadog, but the dashboard wasn't good, and it's hard to find relevant information. Sentry is also one of the best options for iOS, so we decided to use it on both platforms. StatSig is our experimentation framework. We have some wrappers around it for our injection scopes. And it's actually one of the common issues with all these frameworks, or many of these frameworks, is that they use static instances, and it's hard to deal with injection. For analytics, we use a custom solution based on the Segment open source library. We tried Mixpanel, but it got too expensive quickly at our scale. For logging, we use Datadog. It's expensive, but it's great if you can integrate it across your stack from front end to back end. And we also use Google tempering protection for our binary. So we use Dagger and Anvil for dependency injection. We looked into using Hilt originally, but it just didn't handle user scopes as well as we wanted it to. Originally, we had app and user scopes. There was no support for multiple accounts. So the app is the global scope. Things like Logger and Analytics live there. So user scopes corresponds to the login. Then we added user account scope, which is basically an account under login. So you can have enterprise and personal account under a single login with ChatGPT. Yeah, and eventually we felt like we need a conversation scope. That way we can share information between screens. For example, if you go to conversation details, or when you switch between voice and chat mode. And this is just an example, a good example of scoping with our preference stores. So, for example, logged-out user can have access to the global preference store and logged-out preference store. And when you log in, you get access to global, user, and user account stores. And they automatically clear when you destroy the scope. And I think dependency injection is one of the important things to get right from the start. So here are some more details about our dependency injection. So we have separate coroutine scopes for each of our dependency scope. And that way we can automatically cancel all the relevant tasks when a scope is destroyed. It also applies to Compose. That's one of the unconventional things that we have. We actually create a separate Compose view with custom coroutine scope that matches injection that we inject to the ViewModel. That way we don't have race condition. For example, when you log out and there's a screen transition, the old screen is not rendered anymore once the scope is destroyed. We had some issues with Anvil, where it wouldn't regenerate some code in some corner cases. But I think it's still worth it to avoid a lot of boilerplate and injection. And lastly, we have something we call release completable. It basically lets you run tasks when a scope is destroyed. For example, as I mentioned, when you log out, we want to delete preferences and some other files that lets you do that. And just an example on the slide. Navigation, we use standard Compose navigation library. We have a top-level view model that controls global state, things like login, service availability, so that navigation graph, for the navigation graph, we set start destination depending on that global state. That's not ideal, and apparently it's a misuse of the library. You shouldn't change start destination. On an existing graph, it can fail on restoring the state when the app was killed. So our navigation graph is flat. So basically, all screens are defined at the top level. So far, it works pretty well, but we might have to split into subgraphs, and that might be a solution to our start destination problem. We use a custom destination class for routing. I'll have some details later on that. And overall, I think our experience with Compose Navigation Library was that it's not ideal for pure Compose applications. It's built with kind of like event-based system in mind, not declarative one. There are some third-party ones, third-party libraries that you could use that are designed purely for Compose, and where you might even consider something custom at some point. So if you're just starting an app and you expect it to be fully Compose, I recommend looking into some alternatives. This is what a stripped down and oversimplified version of our main activity looks like. So we have a global app component that creates a root view model. You subscribe to its state, and then out of the state, you can get the start destination screen. And then we pass it to the nav host. Nav host defines all of our screens. The composable function here is basically like a thin wrapper around the standard composable function in the nav host. Yeah, and the real main activity is obviously quite a bit more complicated, but this is some of the most important stuff. And the destination class, as I mentioned, we use it for routing. So it's defined in a separate lightweight module. It's basically a sealed class, so we make sure everything is defined in one place and easily maintainable. The drawback is when you change that module, everything needs to be recompiled because everything needs destination. So far, it worked pretty well, but we might have to change it in the future as we grow more. It can take type parameters, mandatory or optional. Everything is done in a type-safe manner. Yeah, but many of our screens are very simple with no arguments, and this is just an example on the slide there. So our screens and all other feature-level components use standard Android view models. We have a thin wrapper around it. The original version is here on the screen. It took less than 50 lines. It basically handled state and events for Kotlin flows. The current version is a bit more complicated, but mostly we just added some helper functions. For example, for piping data from external flows into state updates. We also added a sealed class for standard effects versus explicitly defining effects for each of the screens. Things like navigation, showing error pop-ups, intents, those are useful for many screens, so it doesn't make sense to duplicate those. So as you probably noticed, we use unidirectional data flow in our view models. So we have a mutable state that's delivered to the UI. So the whole view model state is a single object. UI can send events to the view model using something we call intents. So things like button clicks, input edits. In turn, view model processes and updates the state. We still use remembered functions in Compose for things like if you have an input that doesn't require any processing until some button is pressed, for example. So I mentioned effects, so it's something that ViewModel can send to the UI layer to, for example, to display errors, to navigate to another screen, so something that only UI layer can do. And each ViewModel declares sealed interfaces for intents and effects. That way, we can ensure that Kotlin compiler can enforce that we handle everything explicitly and don't forget anything. Yeah, so in our app, we use Compose almost exclusively with a very few exceptions. I think that's one of the main reasons we were able to move so quickly and iterate on new features and build the app from scratch. We also use Material 3 UI library with some theming in a small number of custom components. As we grow, we might drop it, but so far it served us pretty well with limited design support that we have. But here are some of the places where we still need to use old views. So we have a bunch of web views across the app, some camera screens, and some third-party integrations where we still need to deal with old views. We also need to customize the old-school view theme to apply our styling to things like status bar and loading screen. And this is just an example of what our app looks like. The screenshots might be slightly outdated for now. I think it looks quite a bit different. We also support tablet layouts, but it's only customized for very important screens, like the chat screen you see here. For most of the other screens, we just add paddings on the sides, so it looks good on large tablet device. Overall, our experience with Compose was great, but here are some of the pain points I wanted to mention. So there are always some small issues with text fields. For example, it doesn't support autofill hints. There are always crashes here and there. I think the Compose team is aware of most of that stuff and will fix it eventually. But yeah, typical stuff works pretty well. Some people are concerned about performance on long scrollable content. It works well for us, but maybe it's because we're using pure Compose for everything. If you try to mix old views, you might have some issues there. Material library is great, but it's missing some components that we would like to have. For example, it doesn't have a good customizable calendar. In those cases, we have to roll out a custom solution. And my personal opinion is it's a bit too customizable for a small team and limited design resource. It's hard to come up with a proper theming that matches other platforms that we have. Let's switch gears and talk about networking a little bit. So I mentioned we use Ktor for REST APIs. Under the hood, it basically uses our HTTP engine. Originally, we thought we might share more code between platforms, so we lean into like Ktor because it supports multi-platform. And we use Apollo for GraphQL APIs. It's pretty much the industry standard for mobile. We also attempted to use WebSocket to reduce some overhead of SSE streaming that we have. Originally, we used to send whole messages once you get a batch of tokens from the model, and it's very wasteful. But eventually, we fixed it by just sending diffs, JSON diffs. So we have injectable clients for most of our injection scope. For example, there's unauthenticated, authenticated client. There's one for user and user scopes. Basically, it matches our injection scope. One of the important decisions we had to make when we started developing an app is how to propagate API results through the code base. We considered exceptions, Kotlin result, and something custom. Exceptions were not a good solution in Kotlin because there's no strict throw declaration, so it's hard to know what you need to handle where. Kotlin result is better, but there's no standard typing. So you cannot declare types, different types for errors. In the end, we decided to create a custom result sealed class. That's what you see on the screen here. It basically has some generic error subtypes that we can handle differently in the UI. And the nice thing is we use it across the app, so it's easy to propagate everything, the result where it makes sense to handle it. Usually, it's a ViewModel layer. Why do we use GraphQL? So the main reason is we want consistency between backend and front end. We move quickly, so sometimes we have breaking API changes on the backend that are not synced to the client. Yeah, so sometimes there are assumptions about format for some fields in the JSON. GraphQL solves most of those problems. It also helps to reduce payload in some cases. For example, in GPT Store, previously we had like a massive JSON just to show an icon and text in the list. And finally, it's letting us generate clients' models, domain models on the client automatically, so you don't need to worry about manually defining them. Full disclosure, we actually paused this effort recently, but mostly because we don't have backend resources to support it. Hopefully, we'll continue at some point. So now I can talk about some interesting stuff we do on the model side to support mobile clients. The system prompt is actually slightly different for different client. We pass some basic information about the app, for example, the fact that it's an Android native app, so the model is aware of the client type. On mobile, we also request shorter responses where possible to cater for smaller screens. We also had cases where we explicitly asked model to not output certain types of content, for example, LaTeX formulas when we didn't support it on Android yet. Overall, it's a tricky business. When you customize system prompt, the response might get worse in some cases. So if you do something like this, make sure you test it thoroughly. So the chat is obviously the main part of our app. When you message ChatGPT, the response is streamed back as tokens become available. Almost always, we get a markdown from the model. It could be tricky when you're streaming because you could get partial formulas, for example, or a table that's not fully sent to the client yet. We do have some heuristics to handle it, but essentially you can still see some broken markdown when we stream. We used to add animating cursor at the end to show the streaming is in progress. On the web, we actually do smooth streaming, so you get large batches of tokens from the model, but we break it down character by character and animate it. On mobile, we tried that at the beginning, but because the initial batch is pretty large, it usually fills up the most of the screen on mobile, so we decided kind of against it. But recently, we did add some nice animations to mobile apps. We also support multiple scroll states, so by default, you get the current response. You start reading from the top, essentially, but you can switch to auto-scroll to the bottom or a custom position. So one of the interesting things we do is the way we render content. So as I mentioned, we get markdown from the model. We use for Compose rich text library that renders markdown in Compose natively, but it's heavily customized for our needs. For example, we do parsing outside of the library. We need to support custom content like LaTeX formulas, charts, search widgets, etc. Model also supports multimodal content, for example, images. You can either upload image to the model, or it can generate DALL-E images. And Markdown does support images, but it's actually sent separately from the model. And on the screenshots, you see some examples of that. So we have Markdown on the left, DALL-E generated image in the middle, and then there's a LaTeX formula on the right. I don't know if you can see that. But we actually render it in a small web view in a text block, because apparently the best library to render LaTeX is a web-based. We also experimented at some point at passing additional context to LLM. It could significantly improve quality in some cases. For example, simple locale can help model cater response to a specific user. For example, it could be he uses right measurement units or right time formatting, etc. More accurate GPS location can help with location-based queries. It gets tricky with privacy, though. You don't always want to share user location. Ideally, you want model to ask for it, but then you get a round trip to the model, which is really slow. And then we can also use a whole bunch of external providers like calendar, contacts, etc. But again, it's hard to get right with privacy there. Let's talk a little bit about challenges of scale. We spend a lot of time chasing crashes. So with the scale, you kind of have even small crashes can affect significant number of users. On the plus side, though, you can quickly validate a release just by sending it to 1 or 2% of users, and that's what we actually do during our release process. We send to public beta at the same time we send for regression. Yeah, so there's a lot of vendor-specific issues we have to deal with. So, for example, our web-based login doesn't work on some devices because they don't have a proper browser set as a default. As I mentioned before, we use a lot of external services, and with scaling and as we grow, we start hitting limits and it gets expensive. For example, Mixpanel we don't use anymore because it's too expensive. Datadog is expensive, and we constantly hit quotas there. Compose is another big source of bugs when you have a lot of users. We constantly hit some small crashes here and there. And usually it's somewhere deep in Compose where we cannot handle it ourselves, so we just have to wait for Google to fix it for us. In fact, many of our top crashes are actually Compose bugs where we couldn't find any workarounds. To be fair, though, I think even knowing this, Compose is well worth it, considering it improved our velocity so much. One of the last things I want to talk about is abuse. So ChatGPT provides free and fixed price access to LLMs that are really expensive to run. So people try to abuse it to get basically an API access for free or cheap for their own use cases. That's, for example, one of the reasons we had or still have a phone number requirement during the registration. We often get frustrated Google Play reviews saying that we're trying to collect the phone numbers. That's actually to fight abuse in our case. We also have captures in onboarding. That's part is frustrating for us developers because we often need to create new users for testing. And finally, we use Google Play integrity. We use both validation and tempering. So validation helps you validate that it's a real device and not an emulator, which we block usually. And tempering is a relatively new thing. It basically instruments your app to prevent tampering with the binary. Works pretty well, but it did cause some crashes early on, and only on the build we uploaded to Google Play. here's some of the other things I wanted to cover. So we use coroutines everywhere. At the beginning, we had we did consider whether it makes sense to fully commit to it, but we did, and it's great. All our dependencies support it. Sometimes it's the only option. For example, Compose. Basically, no regrets about using it. So we use unidirectional flow and Compose. So ideally, our data models need to be immutable. But Kotlin collections are actually mutable under the hood, and Compose knows it, so it can result in some performance issues. So this means to solve it, we either need to use Kotlin immutable collection, which is a pain, or mark our models as immutable explicitly. So that's what we do. We actually mark our models where needed as immutable. I believe Compose now have a global configuration for that, so that might be the way to go now. Some people are concerned about overhead of constantly copying immutable state when you update the ViewModel state. It hasn't caused any problems so far for us. And lastly, to mention, for persistence, we use preferences. So we usually serialize data classes in small collections to store it in preferences. We do have SQLite for chats and messages. We use SQLDelite, works okay, but from time to time we hit some limits there. Yeah, and that's all I've got. Thank you very much.
Anton, amazing. Thank you very much, buddy. Just join me over here.